Hey guys, welcome to lesson 1.2 where we talk about categorical data. So categorical variables, as we talked about in the last lesson, include labels and descriptions. And you can't really do math on them directly. We're going to have to shift some things around in order to do math on them. So let's start with the 2020 NFL draft, and we've got the top 15 draft picks listed below. So the draft includes 7 rounds of player picks, and the first 32 players tend to make the most money in their career. So being selected in the first draft is pretty important financially, and for status reasons and such. So actually, one of the guys that went to my kind of small high school in Tennessee was the first pick in the second round. So he just missed out on the first round. All right, so here's the first 15 players, including Joe Burrow, who ended up winning the Heisman Trophy last year, I think by the largest margin in history. So categorical data. You've got NFL team, that is a categorical column. You've got the player name, player position, the college they attended, and the conference. Now, if we organize this data by conference, this is the first 15 players. Out of the first 15 players, 9 of them were chosen from the Southeastern Conference, the SEC. And so 60% of them, out of 60% of the first 15 players were chosen from the SEC, which is a lot. In fact, if we look at the first 3 rounds, in the first round, 15 players were from the SEC, 10 players in the second round, and 15 players in round 3 were all from the SEC. The Big Ten is the second most represented conference. The Big Ten had 5 players in the first round, 7 in the second, and 4 in the third. So we've got kind of two-way data here. We've got the conference. So we've got the 1, 2, 3, 4. We've got the top, kind of the Power 5 conferences: SEC, Big Ten, Pac-12, ACC, Big 12, and then there's others. And then we've got the round. And we can organize this data by making something called a segmented bar graph. Segmented bar graph. So what you have is on the x-axis, you've got the different rounds, round 1, round 2, round 3. And on the y-axis, we've got the relative frequency from 0 to 100. And then on the right side, you've got the legend telling you what different conferences you have. All right, so as you can see, the SEC represents the biggest chunk in both the first, second, and third round. And then the Big Ten represents the second biggest chunk in, well, Big Ten and Big 12 are pretty close in the first round. And as you can see, the other category, this is the other category, as rounds keep going down in value, more and more players are taken from non-Power 5 conferences. All right, so here's my question. The SEC had 15 players. The SEC had 15 players selected in both the first and third rounds, yet relative frequencies, as seen on the segmented bar graph, are different. So here's what this is asking. It's saying in the first round, let me get rid of some of this text here. Okay, so in the first round, this represents 15 players, and this represents 15 players. Yet the relative frequencies are different. So why is that the case? That's the case because the first round and the third round had a different number of players chosen. So the first round had 32 players chosen, and the last one had more than 32 players chosen. So the 15 appears smaller in that round. In fact, if we look at round 3, You've got 10, so this is 25. This is 35 plus 6. You had 41 players chosen in the third round, so the 15 represents a smaller chunk of that. This is 15 out of 41 is a smaller percentage than 15 out of 32. So you can't tell how many players or how many data points are in each segmented bar graph. All you can compare is the relative frequencies, and that's the important thing. So that's what this says. The main thing that's missing from a segmented bar graph is a sense of how many individuals are in the different groups. That is a very, very, very important thing to consider. So a lot of the questions that you will deal with on the AP exam deal with this very concept. You can't tell how many individuals are in each graph. So for example, here's a segmented bar graph for medals won by the top 4 countries in the 2016 Summer Olympics in Rio. You've got the United States, Great Britain, China, and Russia. Which country won the most gold medals? That's the question. And the answer is you can't really tell. Here's what you can tell. From the 4 countries present, Great Britain had the highest proportion of gold medals as a function of their total medals. So out of all their medals, Great Britain has the highest frequency of gold medals. But we can't tell which country won the sheer absolute number of gold medals. But spoiler, it was the United States, USA, USA, USA. But we need a mosaic plot to figure that out. So let's see what a mosaic plot looks like. So unlike a segmented bar graph, where each of the bars has the same width, a mosaic plot has a different width. So notice that unlike the segmented bar graph, the width of each bar is now variable. United States is much wider than the 4 other countries, signifying that they won the most medals overall. When working with a mosaic plot, you're interested in the total area of each rectangle. So now I can tell, if I'm looking at gold medals, that the United States has the biggest area and thus won the most gold medals. Which country won the most total medals? I want to look at which of the countries has the second highest width. And so the United States has the highest width, and the second highest width would be China. So this is slightly wider than the Great Britain one. Around what percent of Great Britain's medals were bronze? So I'm interested in bronze and Great Britain. So I'm interested in this. So what percentage? If I look at gold and silver together, that adds up to about 75. So the remainder would be 25%. Rank the countries by the raw number of bronze medals won, from most to least. All right, sheer number of bronze medals won. So I want the greatest area. So USA would have the biggest area. Second biggest area would be China. The third biggest area looks like Russia. So if I'm looking at this area, that looks bigger than this area. So Russia, and then Great Britain. Do you think China or Russia had more silver medals? Why? So China or Russia? I'm interested in silver medals. So I'm interested in the light blue category. So between China or Russia, which of these? Looks like the Russia one is longer, the China one is wider, so it's pretty close. But I'll let you guys make a decision on that. So that's the key for categorical data. You've got mosaic plots, which have both width and height. We have segmented bar graphs that you can only compare relative frequencies. And yeah. So good luck with the practice set problems for this section.